So last week we spent a lot of time now looking at some of the basic rules of derivatives. For example, let me throw a couple at you. What's the derivative of 5? 0. Okay, why? Horizontal line, slope is always 0. Okay, what's the derivative of x? 1. Okay, what's the derivative of x squared? Okay, what's the derivative of 7x to the third? 21x squared. Okay, so that's the whole power rule. What's the derivative of the sine of x? Cosine of x. Derivative of the cosine of x? Negative sine x. Derivative of the tangent of x? Secant squared of x. Okay, you are going to have to know those rules as though they are like asking you the colors of the rainbow. Okay, they have to be things that are just natural to you that we know. All right, the question that we have today is, now that we know those rules, those basic rules, I want to go a little bit more in depth. So I have a different kind of function up here. The function is x times the sine of x. Okay? It's a function which is made up of basically one function, x, multiplied by another function, which is the sine of x. Okay? So if I multiply two functions together, what is the derivative of that? That's what we want to know. Okay? So take a close look at the yellow dot. Okay? So, by the way, if I take this off, everybody understands that function. That's just the functional value for different x values as x goes from here, -20 to +20. If I plop this guy on it, and I'll take this one off, okay, just to make it not so messy. This green dot tells you what the slope is at any given point. Okay, gives you what the slope is. And to really clarify it, there's that purple tangent line at every one of those x values, and the green dot is telling me what the slope of that line is. And just to clarify a couple of things, notice if I'm right here, which I can't get really on there, okay, horizontal line, well, it's not really horizontal yet, you get the picture, right? Horizontal line, okay, with each of these, where's the green dot? It's at 0. See, it's the slope of the line tangent. And here it's at 0 again. Okay, so every place that I have this horizontal tangent, that's supposed to be tangent there if I can get closer, then this would be at 0. Okay, so what happens when I connect the dots? Well, let's see. I'll get rid of some of this other messy stuff here. The green dot, I'll zoom in a little bit on this. The green dot is the slope of the line tangent to the red equation at any time. So the green equation is the derivative. Now, do we readily recognize that one? Like we recognize other ones in the past? See this weird thing, it's doing this thing. This is the opposite of a dampening curve. See, the further you go out.
It's like a Christmas tree.
I was thinking X-Wing fighter.
It's just weird.
So, this is what's going on here. Okay, so, well, when you don't know how to do something, you find the derivative, then you go to the calculator, the derivative calculator, because it always knows the answer. Okay, so here's my function. Okay, x times the sine of x, and let's see what it is. So plug it in, and what comes out? Like that. This is what it is. So, all right, we better. Mathematics is a study of patterns, so we're going to write a couple patterns on here. So write this down, and let's see what we get. So, first person to recognize the pattern gets a gold medal.
Did you just say Swivl?
We'll come back to it. So, number one was f of x is equal to x times the sine of x. And the derivative of that was, what did it say? It said 1 times the sine of x plus x times the cosine of x. That seems very random. So I'm going to change the function here. To x squared times the sine of x this time. Okay, so now this is a different graph than the last one. So what is its derivative? Well, it's that green thing. Okay, whatever that is. Let's find out what that is. So, f of x equals x squared times the sine of x. Okay. Plug it in the function or the derivative calculator, and we get this. You got the rule? Okay. Okay, hold on to that thought. So, here we go again. Number 2 was f of x is equal to x squared times the sine of x. And f prime of x is equal to 2x times the sine of x plus x squared times the cosine of x. Okay. Megan, you want to try your shot right here?
Like,
Go up there and look at it.
you don't have to bring the Swivl down.
Yeah.
Now.
Yeah, we got to do the Swivl. Okay, talk us through it.
So, it's like...
I'm pathetic. Is the word.
So, it's like...
Get down here. Get down here. Helps if you talk to it. Okay, go ahead.
So, it's like you're distributing it. So, you take the derivative, and then you just...
Never mind me.
So, you take the derivative at 2x. I swear.
I'm a human Swivl.
So, it's like, you take the derivative of the first term,
Okay.
that's 2x, and then you just bring down the sine of x,
Okay.
and then you bring that down for the next part, so plus 2x squared, whatever, and then you do the derivative of sine of x, which is
Anybody else thinking that? Okay. Yeah, there's a goosebump moment. You got it absolutely correct. All right. Awesome. So she was first.
Only need more candy.
Oh, yeah, look at that. Okay, there you go. Nice. Okay, so does her technique work for this one? You take the derivative of that one, bring that one down, bring that one down, take the derivative of that one.
It's all the sugar.
Jeepers.
Yeah, Brendan, who took the bag of candy.
I didn't take the bag.
It was Austin. He brought a bag of candy.
No, Austin took the chocolate bag.
What are you guys talking about?
Yeah, well, how come I didn't get any
We had
candy?
a band piece today. I mean,
after
they buy us more food.
Yeah. Yeah, look at that jug.
You should see my locker, Kayla.
Okay, everybody write this one down now. Write this one down. It's x cubed times the cosine of x. X cubed times the cosine of x. And try to apply the Megan rule.
I like the sound of that.
Let's put her face on the wall.
I get to pick the picture though.
Okay. Simplify it if it needs to be. If there's a minus, a negative in there, make the minus where it goes. If there happens to be one. Here. Punch it in. Ready to go. See how the minus said, it's really because the derivative of the cosine is negative sine.
Wait, is that the answer?
This is the final
Can you
answer.
flip it over again? I had the wrong equation.
Wow. In computer programming, we call it garbage in, garbage out.
Oh.
Or syntax.
Yeah. Yeah.
Is there a difference between f of x and the y?
F of x and y. Okay, great point. So I'm going to talk more about that notation this week.
Okay.
How we can write it like different ways. Okay, I'm going to clear that all up this week. Okay? Raise your hand if you got it right.
Can you flip it over again?
Oh yeah, sorry.
Thanks. I had it right if I was.
You're doing right. Okay? All right, sweet. Okay. All right, last one. It's two functions being multiplied together. The sine of x multiplied by the cosine of x. Okay, got an answer? All right, here we go. Plug it in. Plug it in. And we get this. Sine of, or cosine of x times the cosine of x minus sine of x times the sine of x. Yes. That would be the simplified version. Okay, so cosine squared x minus sine squared x would be the better final form to write that answer. Okay? Good? Now, here's what we do here. Okay? I didn't teach you a thing. You guys figured it out yourself. So now I'm going to have you write the major rule. Today we are talking about the product rule. And so let's write the product rule. Okay, so we're going to say if f of x and g of x are two differentiable functions, yeah.
It's gone.
if f of x and g of x are two differentiable functions. Now when I say that f of x is a differentiable function, that means we can find the derivative at every single point. Okay? That a derivative exists at every single one of the points, no matter where the x is. Okay? Then, watch this. If h of x is equal to f of x multiplied by g of x, okay, we'll say, I'll put an and in here. If f of x and g of x are two differentiable functions, and h of x is equal to f of x times g of x, then h prime of x is equal to, you fill in the blank. Yes.
F prime of x times g of x plus f of x times g prime.
Say it one more time.
F prime of x times g of x plus f of x times g prime of x.
I don't know. What do you guys think?
Yeah.
Yeah, that's correct. Okay. So, f prime of x times g of x plus f of x times g prime of x. Make sense? Everybody gets to be the derivative. Yes.
What about, like, if you were to write x as x times x times x, like x squared as x times x?
Let's do that. That's really fun. So, let's test it. I love that. I'm such a nerd. Okay, so let's pretend f of x is equal to x times x. What should be the answer to this be? What should the final answer be? 2x, right? Because that's x times x. Okay, so here we go. F prime of x is equal to, okay, tell me what to write. 1 times x plus x times 1 equals x plus x, which equals 2x. Therefore, the derivative is equal to 2x. So it works. Okay? What's also fun is if you try something like this. Let's suppose f of x is equal to 3x. That's a product. It's a constant times that. If you do this, what happens to make it work? What's kind of unique that makes it work? F prime is equal to 0 times x, 3 times 1 equals 3. Derivative of 3x is 3. So really, we don't even need that product rule or that power rule, do we? We just know this one, then it's way better. Okay, let's try another one. What about if f of x was equal to the square root of x times the tangent of x?
Oh, now you start.
Am I make? Only really important people use them. Now, I do it all the time to summarize. We set out to do this, and there we did it. So therefore, this is the answer. It's a great way to summarize stuff. By the end of the year, I'll have you all writing therefore statements. Not because I told you to, just because you'll want to. Okay. All right, chew on that one. Go do this one. Go do that one on your own. You don't need me anymore. Simplify your answer. Yeah. All right, you get an answer here? Yes, no? Hey, wait a second. Did we do any square roots yet? Okay. F prime of x equals. So, according to the Megan rule, we got to find the derivative of the square root of x. Okay? So I'm going to do this on the side, so watch this here. I'll have a derivative and put it on the side. The derivative with respect to x of the square root of x. So what's the derivative of the square root of x? Well, it's hard to do in the radical form, so we have to rewrite it. It's equal to the derivative with respect to x of x to the 1/2, because that's what we do know, right? X to the 1/2 is what we do know. Does this fit the model of the power rule? Yes, it does. It's k times x to the n. So what do? We say, well, you bring the 1/2 down. It's 1/2 times x to the 1/2 minus 1. When in doubt, write it out. Okay. So this is 1/2 times x. 1/2 minus 1 is the negative 1/2. Okay. Now that's not good form because we want to put the power that's negative, we want it to be positive. So this becomes 1/2 times 1 over x to the 1/2. Okay. But that's probably should write that back in the form that we had it. So it's 1 over 2 times the square root of x. Okay. The derivative of the square root of x is 1 over 2 times the square root of x. Okay? All right, so here we go. So that one goes right here. 1 over 2 square roots of x times the tangent, we leave that one alone, plus the square root of x times secant squared x. And that is the derivative. Probably could clean it up a little bit, maybe just to make sure that you see it. This tangent of x is really on the top, so it's the tangent of x over 2 square roots of x plus the square root of x times secant squared of x. Sometimes you'll see this possibly rewritten. I'm doing an algebra thing here. Two separate terms being added together. This one's got is a fraction, so I'm going to put the whole thing over 2 square roots of x. Okay? I'm going to add those up, but this guy needs the common denominator. So I'm going to multiply this one by 2 square roots of x times 2 square roots of x. And when we do that, we get the tangent of x plus 2 square root of x times the square root of x is x times the secant squared x. The reason why I show you that is because on the AP exam, this would be a good problem on the AP exam. It's out there. You compute this, and you get this for an answer. And then you look, and it's not one of the options. Great. Okay? That's because what they did is they did this. So you have to know how to do that algebra to get there. Okay? And that's all it is algebra. Okay. So now we can handle any kind of radical. Cubed root of x, so on. All right. Problem on the board. Find the equation of the line tangent to f of x equals that when x equals 1. Okay, this seems like one of those multi-step problems. Remember that? So let's do the steps. First of all, what kind of answer are we supposed to get? Equation of a line. So somewhere when we're done here, we're going to have a y equals mx plus b. That's the goal.
We're going to take up the whole entire board?
Yeah. Well, look at that function. Okay, so here we go. What's step 1? Step 1, what? Yeah. So find f prime. Find the derivative. You're going to notice that in almost all the problems for the rest of this first semester, your first step is to find the derivative. Yeah.
Should we always, when it says find an equation, should we always just infer that it wants?
Do that. Finish that?
Should we always infer when it says find the equation that it wants y equals mx?
Yes. Yes. And the key here is that it's the equation of the line. Yes.
Should we distribute the, multiply it out?
That's a great question. And that's where we got to figure that out, what we want to do. So here's my function. So f prime of x. How do you want to do this? Okay, the two choices that I'm hearing out there. Isn't this a product? Does it fit the product rule that we just created? Yeah, it does. Can we also multiply the whole thing out and then get an answer? Okay, here's what we're going to do. You guys use the product rule. You guys multiply it all out. I'm going to do both of them.
They'll still beat us.
And we'll, if all is right in the world, the two will be the same. Get that? Okay. Oh. There's always a way. It's a different problem. Okay. Do we agree? Which way was easier? Actually, this way was easier. Yeah, this one was easier over here. No, they're about the same. I felt like when I was doing it, it was easier to find the derivative of this one. Okay, but we get the same. So what we've actually done is shown that, once again, that the product rule works. Okay, which is kind of big, that thing works. Okay, well that's step one. Okay, we needed more than the board, just so you know. All right, step two. What would step two be? Okay, so we're going to find slope. Okay, now when we find slope, what we're really doing here is we're finding f prime of 1. That's the slope. We want to find the derivative when x equals 1. Okay, so let's go find that out. F prime of 1, f prime of 1 is 4 plus 6 minus 6 minus 5. I got negative 1. Okay, so, just so you're understanding, f prime of 1 is the slope of the line tangent to this wacky curve, whatever it is, when x equals 1. And the slope is negative 1. Okay, step 3. Find a point. Okay, so we find the point, and to find the point, we're finding f of 1. Not f prime of 1, but we're finding f of 1. So we go back to the original function and plug in 1. -3? So that means this. 1 comma -3 is the point. Plug in an x, you get a y of -3. And finally, step 4. Now we do the equation. So y minus y sub 1, well, let's just plug it in. So y minus -3 equals -1 times x minus 1. Right? Y minus y sub 1 equals m times x minus x sub 1. And then just clean it up. This actually, if you're rushed for time on the AP exam and they tell you to find the equation of the line tangent, you can stop right here. Because this is actually the equation of the line tangent, and it happens to be in point-slope form. So this is a legal equation. Okay? To have it sort of make sense to us, we put it in slope-intercept. So y plus 3 equals -x plus 1. So y is equal to -x minus 2. Make sense? Okay. Now, we can draw that equation. We can draw this line. And at the point where x equals 1, those two should be, that's where the tangent, that should be the point of tangent C. Okay? Should I do it? Want validation? Okay. Somebody erase the middle there while I do this. Come on.
All of it?
Yeah.
You said the middle part.
Just the middle part. Well, I think I can get the rest. What was this? X to the third
Oh,
minus 3x plus 1.
might want to clean the board down.
X plus 2. Okay. So that's that. That's the equation.
It doesn't come up.
And then what did I say? Y equals -1x minus 2. So would you look at that? So backing up, here's the big weird function. Okay. And if I go right here at the point -1, 2, or probably -1, 3, that's where the line is tangent. You see the visual connection to what we just did? That's good for you to see what we just found. Hey, does it look like it's tangent here too? Huh. Well, that's weird. You could try when x equals 2. That sure looks like it, doesn't it? -2. I will do that. So that means the equation of that line is tangent to the graph at 2 places. All right, do your homework. Do your homework. And I'll see you before 5 tomorrow.